We Share Solar has an entire collection of curriculum that you can use. To get there, you go to We Share Solar's website and you'll have to make an account with them. And when you go to your dashboard, you can see all the courses you're associated with. So our school had gotten into the international deployment, but what this looks like is their entire curriculum is set up to the point where they broke it down into different segments. So if you want to introduce the Solar Suitcase, there's a video that you can go through. It's a blackout video, which is very powerful in itself. There's some of the equipment, there's thoughts about the program, and then when you are starting to get into the STEM stuff, they go through each of the curriculum sequences. So if I was to open this up, you would see that they have made a Google Documents, and you're able to click on a link to get to their Google Drive. You're able to see the lesson activities step by step. So if you go through and read this and realize like, hey, I kind of want to go more in depth on the developing STEM identity, you would click on the first lesson and it would take you to their Google document with that lesson. So they go through the 5E learning model: engage, explore, explain, elaborate, and evaluate. But they go through and they say roughly how much time it takes. And they have more links to make things like these cards. They have it all laid out for you. And they have some cultural references for like Moana, I think. I'm not sure. But this is part of the curriculum that they offer. And when you go further in depth on this, you can go into global energy access. So I did this with my students. The middle school, that's what MS stands for. And then there's a high school lesson plan, which is HS. You can go through each of these, and these ones are all tailored to specifically global energy access throughout the world. It gets kids to kind of think about this is more than just building a solar suitcase, more than just doing electricity. Why does this matter? And when you get ready to look at solar panels, they also have more in-depth lessons. They have jigsaw lessons, so you could have each group read different parts of an article or different article themselves and then come together. And they have it all laid out of how to implement that. When you go through and you're about to build the solar suitcase, they have 19 documents referencing how to build the suitcase itself. Some important ones are the wiring diagrams, which are all in the workbook, but you can see these online. So if you do not have the workbook, you could also post them online for students to access. And there is safety tips. There is going to be some other ones about disassembling it. A big one that we'll talk about later is a clamp amp meter, how to use that, how to go through and implement once you have the suitcase built. All right, how do you go through and collect data? And then they have some other videos referencing specific building parts. For the part 4, this one is, we'll go more in depth on this with the mini solar panels, the motors, and using FET simulations. For part 5, they talk a little bit more about the language of electricity. And they have posters, they have different middle school, high school lessons that are relatively the same content. They have some more FET simulations. Part 6 is using the solar system for climate resilience. And then lastly, part 7, if this model is changing, but this is talking about the deployment of the solar suitcase. As of 2025 in June, they're going to change their deployment strategy. So this content right here might not perfectly fit for the school year of 2025, 2026. And then they have additional resources. So this is the online version of the assembly guide. There's a physical copy that comes with each solar suitcase. The learning kits are different than the deployment kits. Southeast Service Cooperative has 30 learning kits that you can check out. Right here, they go in depth on each part, the assembling and wiring of the suitcase. Kids are gonna follow step by step of how to build this. So this starts on page 14. And then the quality control starts on page 41. So going down to page 14, the first few pages here kind of go over how the suitcase works, why it was built, how these things help. There's a lot of useful analogies that will be referenced. So waterfall analogy. And starting on page 14, there is a diagram that's going to go through step by step of how to build this. This is what your final product will look like. The blue box has a motherboard essentially that the kids assemble. They're going to wire and screw each part into this white piece right here. And then they're going to be responsible for putting the wires in the right spots. The quality control will ensure that the suitcase will work. The safety for this is covered on page 21. So according to the assembly guide, there is step-by-step directions. Step 1 right here says to install the solar receptacle. This is very important to pay attention to. You need to be able to read all the words on here when you have the battery closest to you. So this says install the solar receptacle. You can see right here that you're going to put the solar receptacle through this spot marked right here, and you're going to tighten it with these 4 bolts. From experience, as of 2025, this does not sit level. So you're not going to get it to perfectly sit level. You can get by with 3 screws, 3 washers, and 3 nuts. You don't have to have 4. If some of the parts are missing, it's not the end of the world. This is the most breakable part. These metal teeth right here, when students or adults go to take out the wire and they try and wiggle it to gain some leverage, that is when some of these teeth break. I'll go over that when I build the solar suitcase. The next step is installing the large main switch. So you'll see right here that it goes step by step. You need to be able to read this when it's in. This piece right here, as of 2025 in June, this has been staying in the suitcase. It's not been taken out. Once it's in, it's in. Typically, we like to have the red wire at the top. If it's been done the other way around, it's not the end of the world. When you go to plug the battery in, you just have to plug it in differently. This is another example of how you need to be able to read these when you have the battery facing you. So if the battery is closest to your stomach and you're assembling this, you need to be able to read the word lock point. And the directions just keep on going step by step. Some of these pieces might be missing, these plastic bushings. It's not the end of the world. All you need to tell students is to be careful with the wire when they go through. If the plastic bushings are gone, the metal could then rub on the wire a little bit more. The plastic bushings are there to prevent the wire from rubbing directly on a metal surface. The charge controller is typically something that's coming in a cardboard box. If it's not in a cardboard box, it is a black device. And this will go through and it will help the battery control where the energy is going. When you screw these out, they do not have to be all the way screwed out. They just need to be raised a little bit. When you get the wires, all you have to do is braid the end of the wire together and stick it underneath. This is essentially going to create a metal-metal connection. Metal conducts electricity. When you have the metal end of the wire touching the metal part of this plate, and then you screw it down to hold it tight, the electricity is able to flow from A to B. This is kind of what the motherboard is going to look like when it's fully assembled. And then after this, it kind of goes a little bit into the flow of electricity. And then there's going to be a series of different wires your group will get. Most likely, you do not have to remove the insulation from the wire. That's already been done from the previous groups I've gone through. When your groups use this, they need to pay attention to the ending of the wire. If they just grab a wire at random, they might grab the wrong one. They might install it and realize, hey, I have the wrong ending for this. This is what I was talking about with the charge controller. When you upload or when you unscrew the terminal screw and you put the wire in there, you screw it back down and it creates a metal-to-metal connection. And going back to the piece that breaks the most, you'll see that when you have the solar receptacle and you're going to connect it to the switch, you put the wire on the metal tooth, so to speak. And if you go to take that off, or if you wiggle it too much back and forth vertically, that is when they break. And when they break, it doesn't work just by rotating it. It needs a new piece. Going through, they have everything color-coded, which is really nice. Typically, yellow or any sort of color of a wire is going to carry a positive charge. Any darker color typically carries a negative charge. That is how most electricians go about wiring different circuits. They're going to pop this wire up underneath, and they're going to attach their first wire to the positive terminal. So this is for solar, it's going to be solar positive. You don't have to over tighten. And one technique, which I'll show you when we build the suitcase, you take that wire with the loose strands and then you braid it. So you just go through and you make sure all those loose wires are going to be in nice one cohesive structure. You don't want the fraying wires to touch other terminals, because then your connections will not be secure. And then this is going to connect the negative side of things. So they're going to use a neutral color, a light color for a negative charge. And then they're going to go through and they're going to add this in. If your students or yourself, if you get overly excited about unscrewing all these and you're missing this piece that the mouse is touching, that piece slides out. So all you need to do is put it back in and tighten it down so you do not lose it. But that piece that looks like a C and it's a piece of metal, that piece might come out. It goes to the negative load and it goes to the port that's called sealed or flooded select. This is a wiring schematic, so you are taking the motherboard. You do not need the battery in at this point. You can gently pull the battery out. Don't try and wiggle it too much. You're going to set the motherboard upside down. The solar receptacle is going to go in the top left of your motherboard, and then the solar receptacle will be in the top right. The DC light receptacle will go in the top left. So when you are wiring this, you see exactly what they see. And then now you're going to go in, red wire is going to be used to connect the battery terminal, and that's going to go up here, and you're going to systematically work your way from left to right. You're going to do the battery negative next, and eventually you have your battery circuit complete, and you'll be working on the load receptacles. These are called alligator clips, and when I build the suitcase, I'll show you. These alligator clips are really nice. They have little fingers on them. They do need to be all the way up. There's a metal strip all the way in the back of it, and when the wire touches and it goes in there and then you clip it down like this, that wire is touching the metal strip, and that metal strip, metal conducts electricity, it will connect all the wires in here to the same connection point. And that's what you need to do. Pay attention to the blue wires and the white wires. It does not necessarily matter if you have it in the first 3 spots. Like I said before, there's a metal strip that will connect all 3 wires. So if you went in the left side, skipped one, middle, skipped one, right side, they would still be connected. This is how they wired theirs up, but you do not need to copy that exactly. It is helpful to have the same setup, however, where you got a plastic ending cap, the loose wire, and then a plastic ending cap. Now you're going to go through and you're going to hook up some of your light receptacles and then your other charging point receptacle. That is going to go into load. And the schematics kind of go into the negative part. Once again, the light colors, the neutral colors, those are carrying a negative load. And you have now completed the entire circuit. So once this is finished up, it should roughly look like this. When you flip the controller back over, you are now going to be able to do your first set of quality control. So this is what I talked about. When you have that battery closest to your belly or your stomach and you're assembling this, you need to be able to read everything. So where it says lock point, that should be legible, not upside down. And this is the first set for visual inspection. If you have a group of students that one student is particularly wants to be super hands-on, maybe they should be the engineer. And if another student wants to help out with building it, because to be honest, not all kids want to build this. They want to be a part of it, but they don't want to wire it. Another kid could be quality control, so that way it ensures they take turns doing things. This is going through setting up switches, and this is the breaker, a 6 amp breaker. So if for some reason you pull too many amperage, this will break. I haven't had one break yet, and I've had 180 kids go through this, but we've only used a light, and we've only charged one phone at a time, so we'd never try to do too much, and I would not suggest doing any more than that. You do not need to overly tighten everything. Once again, 3 screws, 3 washers, and 3 nuts will get you by if for some reason the 4th one is missing, or when they drop on the ground, they disappear quick, so I would definitely try and find it right away. Once again, the solar receptacle does not sit level. So when you go to put that in there, it's going to just sit at an odd angle. I'm unsure of why that never sits level. This is the part where it breaks. So when you go to take these off, you need to be ultra careful about the way that you wiggle it. It's not going to come off easily just pulling straight, but if you bend it too much, that metal tooth is going to go with this. If for some reason this happens and it does break inside that wire, I would suggest having a needle nose plier on hand, and then you can go ahead and take that metal tooth out of there. You can still use a wire, however, the solar receptacle is just not going to be able to be used. You can still do the rest of this assignment, just not the worksheet with the Solar Suitcase. If you break the solar receptacle, the battery still works, the load still works, and the other load, the charging the cell phone, still works, just not the solar panel. This is providing caution. If you notice any wires are fraying out with the insulation, you should definitely let a teacher know. And if you are a teacher, you should definitely have some sort of electrical tape that you can use to cover that up. However, if this does happen, I would let Southeast Service Cooperative know. And now you get into the part that a lot of kids find fun. It's going to make a lot of beeps. This is called the continuity test. So if there is indeed a complete circuit and you go to use the multimeter, it's going to make a good solid beep. Right here is the multimeter you can use. If for some reason they choose to use the other multimeter, the clamp meter, that would work too. But this is the one that they suggest using for the quality control. This is a home run cable, and what a home run cable means is that it's going to take the solar panel and it's going to connect it to your motherboard. This part right here, this adapter, to plug it in, you have to push it in and twist. To take it off, there's this little lever part. You lift it up and then you twist the other way, counterclockwise, to pull it out. You're going to use the alligator clips with only three fingers on them to connect it to the solar panel. This page tells you how to set up your multimeter. Some of the multimeters, the battery has been dying. If that's the case, patiently try and encourage the student to take a turn and use in other groups. If you are able to charge it or get new batteries, that would work too. There is an infographic right here that tells you it's set to continuity. You need to have the 2 leads plugged into COM, and then this other port, red is going to be positive, black is negative. This does not necessarily matter if you follow red is positive, black is negative. If a circuit's complete, a circuit's complete. It's going to tell you that. This tells you how to put the home run cable, attach it to the solar panel, and then these are symbols. So when students are reading this and it says, hey, put the positive terminal black with the red wire, what's the positive terminal? So then they would look up here and they would try and decipher what does positive terminal mean. Once they put in the home run cable, they're going to insert the positive terminal, so the red lead, into the alligator clip, and then they're going to have the black lead and the black one, and they're going to touch it to, if they follow the directions, they have the main switch on, they should hear a beep. The black one needs to touch the charge controller solar positive screw. So if you don't know what that is, the terminal screws are right here, and if you look at the left side, the symbol on the charge controller, it's black, it's on the motherboard, it has a positive symbol, and that's going to be a colored wire. So that one's going to be yellow they chose yellow for the sun, I'm assuming. So they should hear a beep, and that tells us that, hey, this is actually set up correctly. They also have the symbols right here. Step 2, they're going to turn the main switch off and they're going to test it again. When the switch is off, it breaks the circuit, so they should hear no beep. For step 3, they're going to go on and touch the positive terminal block to the negative terminal block. So they're going to have the charge controller solar negative, so they have the black lead on the charge controller solar negative, and they're going to put the positive lead on the home run cable in the negative part. They should have a beep sound. Now they're going to move on to battery circuit testing, and they would have the red lead on the battery port positive, so they're going to go look at battery port positive on the charge controller. They're going to touch the other probe, it doesn't matter which probe it is, to the charge controller battery port positive. So the battery port positive is right down by the battery, and it's the one with the red wire coming out, as shown right here. And then the charge controller battery positive is right here with the red wire. They're going to turn off the main switch and do the same exact test. They should not hear a beep this time. For the battery port positive negative, they're going to follow these directions. They should hear a beep. And as you kind of got the notion of this, if students follow step by step, this is where they can find each of the spots to test. This graphic shows when you should hear a beep. This one shows when you should not hear a beep. Eventually, when you get towards the end, you're going to test the simple connections on the charge controller. And one thing I would definitely advise is before students move forward with the entirety of this is not to have the light bulb plugged in whatsoever. One thing that you should definitely know is when they're using the light receptacles, there's a metal plate at the bottom and then there's a metal plate in the sides. Those carry different charges. One's positive, one's negative. If you look at the schematics on this workbook, you'll see which one is which. I would share the light bulb moment with everybody, so I would not have anybody plug the light bulb in. I would wait till everybody has passed quality control. If you pass quality control, your suitcase is going to work. Your light bulb is going to light up. I would suggest making a big deal out of the light bulb moment. I would have everybody ready, turn on the main switch, do not turn on the light, and then turn the lights off in the classroom, and on the count of 3 or something to that effect, I would turn on the light altogether. It's a pretty cool moment. A lot of kids said it's their most favorite moment from the project. When you're done, make sure you turn off the multimeter so that way the battery doesn't die. And this right here goes into depth on how to put the battery in and ultimately how to plug the battery in. You do not need the battery plugged in for the quality control. To connect the solar panel, they have brown going to black and they have red going to red. Some of the solar panels have blue wires and brown wires. You're just gonna have to pay attention to what it says on the back of them. And then the solar panel, once it's plugged in, it should be able to charge. You have to go outside. The photons from the sun are not the same kind of light from the classroom or from somewhere indoors. So the indoor lights are not going to power your solar panel. You need actual sunlight. And then this is what it looks like when the light bulb is on. If you do, due to international deployment of a suitcase, there's about 5 or 6 of these light bulbs. The solar panel itself is going to be a much bigger one, upwards of 120 watts. It goes on the roof. And then these 5 or 6 lights can power a school or a room for 70 hours a week if it's fair weather. you will want to find some charging cords for phones. Kids typically have those with them, but you're gonna want, these receptacles come with each where you plug in the USB-C. Those typically come with the Solar Suitcases, but the charging cords for a phone do not. If your school has a cell phone policy, this might be one day where it's okay to break that because they can physically see my phone charged 6% since we started doing this outdoor activity. The charge controller has a series of lights on them. This is actually very helpful to know if the battery's charged. When you click on the main switch and the battery's connected and everything is wired up, there is a series of diagrams here that explain what each of these mean. Another cool part of this is right here, it says charging status. So if you are actually charging the battery with the solar panel, that light will turn on. One thing I would like to note that if you move forward with an international deployment, my school, Stewartville, middle school and high school, each one has sent 2 cases total. One case went to Kenya, one case went to Uganda, and I was told that they hire local people to install those. So the money that is sent to this company to do this is not just Americans going over and doing it. I thought it was really cool how they hire local people to install these solar panels within communities in their area.